funding for a personal project. So I applied, and then a couple weeks later, I got $3,000 to build one of these. And so now that I actually had the money to build it, I had to really think, okay, how can I actually build this thing? So I realized that basically in the summer, I really didn't know what I was doing, and there were some serious problems with this original design. So some of the problems were, where would you put a 4.5-foot dodecahedron? Would it be on the floor or on a table or in a kitchen or in the living room? It didn't really make sense anywhere. It looked really cool, but it really had no point and actually hurt the function of the garden. So that was a problem. And one thing that really bothered me is you can only grow one type of plant at a time because there's only one grow tray. And also I wanted everyone to be able to use it, and when I started, I didn't really design it to have nice interactivity, and so just my mom could use it, basically only I could use it originally. So then over winter break, I thought about all these problems, and I decided I just needed to redesign the whole thing. And so I first started with, okay, where can this thing go in a house? So I thought, okay, you cook in the kitchen, you store your food in the kitchen, so it should just go in the kitchen. And so I kind of thought about, okay, this can just be right next to the fridge, so I modeled after kind of a fridge. It's 30 inches by 30 inches by 80 inches. And that new design actually solved another problem, which was only growing one type of food. Because there's a lot more height, you can now, I now decided you could actually have multiple levels of grow trays in there. And but one issue is that certain plants grow taller than others, of course, tomato plants are taller than lettuce plants. So what I'm designed it to do is that the grow trays would be easily removable. So for example, if you wanted to grow lettuce and tomatoes at the same time, you could say your 4 grow trays are in there, you remove one so you have kind of a double space for your tomatoes, and then you could have just 2 lettuce plants growing, 2 lettuce trays on top. So you could just really mess around with what you want. And nowadays there are a lot of, it's interesting, there are a lot of dwarf species, so you can actually do a lot of weird things, if you removed all the trays, you could grow a dwarf lemon tree or something. Just some weird stuff. Also, it's not limited to produce, you can grow flowers too, just any type of food. And so the interactivity, I wanted everyone to be able to use it, and I was like, okay, everyone has smartphones nowadays, everyone can kind of use a tablet, so if you just had a really, basically just put a tablet on the front, and I haven't actually designed the interface yet, but it should be a nice interface. And now that there was a tablet on there, it kind of opened up some other possibilities, such as internet connectivity. So now you can easily, you could potentially adapt that application and have it on the smartphone and monitor your garden at work, or if you go on vacation, and it could send you updates easily. And if you wanted to, you could actually share your progress with your friends really easily, on Facebook or something. Yeah. Okay, so how does it actually work? So I talked about what an ebb and flow system was before. Basically, you have a main reservoir, and then you have a grow tray or many grow trays. So this is basically just a diagram of the hydroponic system of the garden. So here, that's the main nutrient reservoir. And then this is one of the grow trays. I only have one in this diagram. And basically, so there's going to be a pump in here, and depending on the plant, it would periodically pump the nutrient solution in there and filter back. All this other stuff is kind of just the environmental controls, which I'll talk about in a second. Okay, so this is actually a power diagram, but it kind of gives a nice overview of all the different types of controls. So there's a CO2 control. So I have a CO2 sensor basically that reads the parts per million in real time, and so that would be in the plant's environment, and depends. So say the CO2 levels get too low, there's actually a 5-pound CO2 tank in the bottom of the garden, and there's an electric solenoid valve. So the CO2 levels get too low, the valve opens until the desired levels are reached, and then it closes and kind of just works like that. I eliminated the fan system, but I have a pump. There's the pump systems. You need there's basically two major pumps. One is to aerate the nutrient solution, because it's very important for the roots to have good oxygen. So you need actually something just constantly running bubbles through your nutrient solution. And then there's the main reservoir pump, which is actually doing the feeding and moving the nutrient solution into the grow trays periodically. And then ignore that pump. And then, then there's the nutrient temperature system. So basically this is controlling the temperature of the reservoir because it's important because if it's too hot or too cold, diseases can grow. There's one called root rot, which is just like a really big problem. So you have to have like really good control. So the way I did that, the temperature sensor, there's a water heater that's kind of lying in the bottom, and then I have a kind of an external water chiller. So basically, if the water's too hot, you pump the water through the water chiller. If it's too cold, you turn on the water heater until your desired levels are reached. This RO system, RO stands for reverse osmosis. I realized that I wanted this garden to be able to work in any house, and depending where you are around the world, your water has certain, like it's either harder or softer. There are like heavy metals in it, possibly. There are different pH levels, and that's really bad for a nutrient solution because you want to know what you're feeding your plants. So this RO system basically takes your input water, and when your reservoir level gets a little low, it will filter your tap water and basically give you clean water that you can deal with. There's a humidity system to control the humidity of the environment. Basically, yeah, humidity is too low, humidifier turns on, and vice versa. There's a LED grow light system. So basically, since it's indoors, you need artificial lighting. And traditionally in hydroponics, you use high pressure sodium bulbs, but these are really hot, they waste a lot of energy. So I kind of researched what NASA was doing, and NASA was using LEDs instead, which is, they're very energy efficient, very heat efficient. And so I actually ordered a bunch of these high powered LEDs to grow my plants. My nutrient control system. So basically, I have an EC meter, and an EC meter is, there are two electrodes, and you, depending on the conductivity between them through the nutrient solution, you can monitor the levels of nutrients in your solution, and depending on that, you can alter your nutrients that way. And finally, I have a pH control system, which I have a digital pH sensor, and two electric solenoids controlling acid and base to kind of monitor that level. Okay, so going forward, so I didn't have as much time as I wanted to this semester just because HardNet there's a lot of work. But so I managed to, I ordered all the parts, I kind of designed the system, I have all of them. I haven't actually been able to test all of them. I've only been able to get the CO2 system working really. And humidity, but I plan on actually shipping all these parts I live in New York, I'm going to ship them to New York and hopefully fix all of them and link them together.